Hello everyone, I am Vishal Saini, student of IIT Delhi. Currently I am doing my internship with the MRC. Title of my project is APY Analysis of Shrimp Farming. Starting with what is the need of analysis of shrimp farming? Before 1990s, shrimps are mostly harvested from natural marine sources, but due to higher value in the market, farmers started inland farming of shrimps. Due to the high nutritious content and many health benefits, now shrimp is consumed globally, and to meet the consumer demand, India's shrimp production is increasing rapidly. And now India is the second largest producer after China. And now to maintain the international position or expanding the shrimp industry more with keeping sustainability in our minds, there is a need to analyze the shrimp farming in India. Next is APY analysis of shrimp farming. APY analysis of shrimp farming is an analysis based on area under farming production in an year and a yield which is basically production per unit area. This analysis can be done using mathematical and machine learning models. The main three purpose of this analysis is: first is analysis of production trends, second is identifying reasons for low production, and third is the scope of improvements. Using results of this API analysis, we can take better technical and governance decisions. Starting with production trends. This is a bar graph of India's shrimp production in last 11 years. And from this figure we can see that India's production scale is continuously rising. And for doing shrimp farming, there are certain conditions are required varying from environmental to physical. Environmental conditions are like what optimal levels of water parameter like pH, dissolved oxygen, chemical content like sulfur, etc. There is a requirement of soil quality, topography also, and physical parameters are like availability of hatcheries, labor, processing units, market, logistics, and connectivity. Considering these conditions, currently shrimp farming is carried out in coastal states of India like Gujarat, Maharashtra, Andhra Pradesh, Tamil Nadu, Orissa, West Bengal. But the contribution of each of these states is not the same. It differs a lot from state to state. With Andhra Pradesh is the major producer of white leg shrimp with a contribution of nearly 72%, whereas other states have less than 10% of contribution, with some states like Maharashtra have less than 1% of contribution. Hence, India's shrimp industry needs depends on Andhra Pradesh mainly. So to expand, India has to increase its production in other coastal states, while maintaining the production of Andhra Pradesh. Next is reasons for low production. Some of the identified reasons are like: first one is the disease outbreak. Shrimp industry is prone to many disease which impacts production. Due to outbreaks, farmers have to face many economic losses also. Second one is the informal management. I think there is a lack of awareness among farmers about the assistance provided by the government or private organization. Also, shrimp farming lacks of community-based culture. Third one is the unintensified culture system. In India, each shrimp farmer have 3 hectares of land on average. Hence, production is not that much of intensified. Fourth one is water pollution. As shrimp farming is rapidly expanding, it is forming many environmental challenges like water pollution also, due to the release of untreated water effluents in open water. First one is unsuitable site. There are areas which don't have proper drainage systems, and mostly these farms are located in the outskirts of coastal region, which increases the logistic cost also. These are some of the identified reasons for low production of shrimp. Next is analysis of a factor which directly impacts shrimp production using a mathematical model named analytical hierarchy process. The process of this method is starting with the generation of a pairwise comparison matrix of all the considered parameters. After that, normalize that matrix and calculate the relative weights for each parameter, and from obtained relative weights calculate consistency ratio. If the consistency ratio is less than 0.1, then our assumptions are correct, and if not this is not the case, then we have to redo the same process till the consistency ratio is less than 0.1. In this process, I have considered five parameters for shrimp farming. First one is the pond area, second stocking density, third is the quality and quantity of feed, fourth is quantity of fertilizer, and fifth one is the number of laborers. Doing the same process which I explained, I got this result in which I obtained the normalized matrix, and from that I calculated the priorities of each of these parameters, and on the basis of priorities I ranked these parameters in rank these parameters. The ranking is like this. First one is the quality and quantity of feed, means that any production of shrimp mainly depends on quality and quantity of feed. Second is depend on number of seeds, and third one is it depend on pond area, and at second last it depends on quantity of fertilizers, and lastly it depends on number of laborers. So using this method, farmers can do resource management for the optimal production. Next is the possible policy interventions in shrimp farming. First one is the shrimp crop insurance. Due to the high risk, shrimp farming is not covered by insurance firms, due to which farmers face issue with the funds and economic losses. So there is a need of national insurance policy for shrimp farming. Second is the MSP, minimum support price. In India, option of MSP is available in other crops, but not in shrimp farming. Hence, government should start some type of MSP so that it reduces the burden of variable prices in the market. Third one is availability of suitable area. Mostly suitable area is present in coastal areas of India, but till now nearly only 50%, 15% of area is used. Hence, there is a more capacity, and all this remaining area comes under the government. So there is a need of a policy for leasing this potential area for setting up new efficient farms. Fifth one is the training centers. Skill training should be given to the farmers in the area like feed cycles, monitoring growth of shrimp, cold storage skills, post harvest management skills. Hence, more training centers should be set up in the country. Next comes the production prediction model. As we have seen, area is a major parameter in shrimp farming. So using area production dataset, I have prepared this model. In this model, I have used nonlinear regression to predict the production on the basis of area in past year. This blue curve is the original one, and this red one is a logistic regression fit. In this, I have tried to fit a polynomial equation on the dataset of area and production. This model can be used to predict the future production on the basis of area. Next is the earlier we have seen the problem of crop insurance in which firms hesitates to give loans to farmer due to risk. But I have tried to overcome this problem using machine learning in which past year dataset can be classified into clusters. Let me explain more clearly. This is the past year dataset of production. Using this, we can classify our data into three clusters on the basis of area, which look like this. So this model can be used by farm insurance firms or some organization to predict the cluster on the basis of size of farmers' land. This model has covered all the risk or disease outbreak happened in past year. So using this model, we can give loans to the farmers. Next is what is the scope of improvement in shrimp farming? First one is shift to indoor shrimp farming. Second is traceability. Third is promote sustainable energy sources. Fourth is improve water treatment. Fifth is avoid use of harmful chemicals. And the last one is improve feed use. Starting with shift to indoor shrimp farms. Currently our shrimp farms look like this left image, in which ponds are set up near to the open source of water. But as our shrimp industry is rapidly increasing, and many experts are predicting that we are going to face a huge crisis in terms of disease outbreaks, similar to the Vietnam, who is earlier a global producer. Now, what's the solution to this problem? Solution is to shift to indoor shrimp farms, which look like this right image, in which artificial environment is created to do shrimp farming. These indoor farms are more intensified in terms of production, along with the sustainability in long term. Benefits of shifting to indoor farms. First one is low disease outbreak risk. These indoor farms have very less disease risk. And second is high stocking density. By shifting to indoor farm, we can increase our production also. Third is limited water use. As these indoor farms tre- use same water by recirculating water to the water treatment plants. Fourth is year-round production. By shifting to indoor farms, we can get all year-round production, which is not the case with the traditional methods. Next is the traceability. Traceability is a way to keep track of any product starting from the raw material, production, transportation, storage, and at last consumers. In shrimp farming, traceability is required as our global importers like US demands traceable shrimps to ensure the food and nutritional security of their country. The supply chain of shrimp farming look like this, in which it starts from farms, then logistic or export, then it reaches the processing units, then after that wholesalers, then retailers, and at last consumers. Traceability is a way to keep track of all these stakeholders. The ways to implement traceability is use of technology like blockchain. Second is certification at each level of supply chain. We can issue certificate to each of the stakeholder of a supply chain, which makes the shrimps traceable. Third is vertical integration. Vertical integration in which one company takes the charge of whole supply chain and ensures the traceability of a product. Next is benefits of traceability. First one is efficient farms. It makes the farms more efficient. Second is sustainable production. By keeping track of resources used, raw material used, we can make more our shrimps more sustainable. Third is improve logistics. Traceability also improves the logistics of a supply chain. Fourth is sustainable access to markets. Traceability makes access of sustainable products to the market. And last is opportunities for higher benefits. In last years, it is seen that traceable products have more prices in the global market. Hence, it increases the chances of higher income to farmers. Next is possible technological interventions. Technological interventions are the technological steps which can be made to develop and facilitate research solution to the identified problems. So some of the technological interventions in shrimp farming are: first one is blockchain. In last slide, we have seen the problem of traceability. So to solve problem traceability, we can use blockchain. Second is machine learning. We can use machine learning in shrimp farming to solve problems like disease identification, planning better feeding cycle, cost analysis. Third is automated machine. Shrimp farming requires lot of machines which are operated by laborers manually. So, new to make shrimp farming more efficient, automatic machines should be deployed. It will reduce the labor costs and risk of disease also. Automatic machines are like automatic feeding machines, water quality parameter measurement machines, aerators, etc. Last is renewable energy. Shrimp farming requires a lot of energy, which increases production costs. So, solution to this is using renewable source of energy like biomass, solar energy, etc. By this, I end my presentation. Thank you for listening.